Hi everybody, my name is Guillaume Salou and today I will talk about text generation inference and about Hugging Face as well. So I'm working, you don't see the slide, but they will come. Yep, here they are. I'm working in the infra team at Hugging Face, so it's very bright, but I will try to ask you a question. I would like to know if you know Hugging Face already. You can just raise your hand. Oh yeah. Okay, great. I will spend a little bit of time in order to explain how we build like products, how we build like ecosystem in order to let everybody know why we worked on TGI. So I said TGI because it's the name of text generation inference. So when I will use TGI, it will be for the project. So let's go. So everything started with like Transformers, and it's not a movie from Michael Bay. It's a paper from Google that explains like a new architecture that will allow you to fine-tune model. Before that, you have to retrain like a model from the beginning, and it was very complicated. You had to spend like a lot of compute in order to train a big model. So it was like the beginning of a new era. So then it was good, but at the same time it was complicated because there were like plenty of model, plenty of API, and so we were like, what can we do at Hugging Face? So we started from the ground with a Python library, which is called Transformers as well. So in order to ease the way to use like those models, to fine-tune them, and to deploy them as well. So it wasn't enough because, as you may know, maybe everybody knows huggingface.co, the platform. If you can just raise your hand in order to, yeah, maybe I will spend a little bit time on it. So the platform is here. It's just like, for me, it's the GitHub of AI. You can upload your model. You can use a model with the library that I showed like previously, and you don't have to care about like the architecture of the model. Everything is like very simple to use, and that was like our goal like from the beginning. So, and then so here is like some figures about the platform. We have more than 1 million of models currently. I mean public plus private because you can have private model as well. So we can have a look at what is a model with the the card of the model, but I won't spend like a lot of time on it. And I will just like want to show that it's compatible with different architecture, different type of model, if it's a PyTorch model, if it's a Keras one. So the usual workflow is you have the model hub, then you can pull a model, you can fine-tune it using some data sets on the hub, and you can push the model back again to the hub. So you also have data sets as well. At the beginning, it was like very useful to see which model has been built from which data set. And if you want to fine-tune a model, you can just pull a new data set and fine-tune a model as well. So we have also the dataset viewer, which is like improving a lot at the moment, and the team is working a lot in order to show like what's inside like a very large data set. So to share if there are some categories and so on. So we train a model and we are ready to go. Huh, maybe not. What should I do when I train a model? Deploy it? No. We wanted to also to work with the community in order to help the community to create like demos. So when you want to create a demo, you can like start to code with like some framework. And just for me, I don't want to use it, and I don't know how to do it. So in the end, we acquired a company, I mean an open source project, which is called Gradio, and we were ready to go. Here is an example of a Gradio application that you can like use. So you have Gradio on GitHub and you can use it. It's very easy, like the application that I show in order to translate like to Spanish. It's just like few lines of Python. And that was like the goal of like the acquisition and to push more with the community and to help the community. So we had like the demo, but how can I deploy it? So again, we worked with the community in order to create like spaces. And it was like, when I started at Hugging Face, it was like the beginning of spaces, so I can speak for hours. But anyway, it's not the topic today, but just to let you know that you can, for free, deploy your own spaces on the hub and use it as well. So it was like a long discussion internally in order to find like the right way to do it. And I think right now we have more than 20,000 spaces that are running on the hub. Anyway, different spaces that you can find on the hub with the latest model. And yeah, everything is Git repository as well, spaces, models, datasets, and so on. So at the end of the day, we did the demo, so we are ready to deploy in production. So we created a new product, some kind of, which is called Endpoints, and the goal is to like scale up, scale down LLMs and models as well. But for us, it wasn't enough. So we started to work on TGI, so text generation inference. And I will spend like a little bit of time to talk about the architecture of TGI because it's very interesting. So we had like two problems to solve at the beginning. We had like huge MML that were like coming from the open source community, which is very great. But at the same time, we have like GPUs with a few memory. So we had to find a way, and a way to do it is to use nickel and to like share the memory between GPUs. For instance, if you want to use like a model with 180 billions of parameters, you will need like 450 gigabytes of memory, which is not possible right now. So you will shard your model using like nickel and multiple GPUs in order to use it. Another like advantage of using sharding, if you want to deploy like one model or maybe two, and if you want to use like it for a lot of users, you will need to scale your model. And again, nickel is a way to kind of shard your model deployment. So it was like the beginning of the journey with TGI. Another like discussion we had internally is, should we put it in open source? And of course, like due to all the reason and due to all the work that we are doing with the open source community, we wanted to put it in open source. So again, an explanation, but I won't spend like a lot of time in order to explain why it's better to use open source versus like starting from scratch is like millions of dollars. And so some of the features that are available on TGI, and I will spend more time on it in order to explain them. So we will see like everything about tokens, how we manage tokens. I don't have a slide to talk about performances, but it's good to know that we have like some kind of benchmark included in TGI. So you can run the benchmark. It will pop a UI in your terminal in order to let you know like the performances of your model loaded on multiple or one GPUs, and to let you like do the right decision regarding the fact that you are looking for the performances of latencies or throughput. And I will talk at the end of the like an example of what we are doing with TGI, which is called Hugging Chat, and we are more looking for throughput because obviously we are sharing like all the infrastructure with the community. But anyway, I will talk about it later. So let's jump into an example. So I want to make a risk analysis for Hugging Face Q4 2023. So I will send this request to the model, and what will happen behind the scene is like a mapping between the tokens and some numbers, because obviously models, they don't understand like string. So Here is like the example of like the answer of the model, and you can pick up different models, obviously. So what is very interesting regarding like all the optimization we did on TGI is at the beginning of our project, we were like, oh, we had GPUs with a lot of compute, which is good for training, and few memory. And at the other side, we have like LLMs. They need like a lot of memory, but a few compute. So we started to do some tricks. So we worked on the cache, on the user side, on the quantization, on the speculation, and we are still like improving the project a lot. So a very simple way to cache the data is obviously to use a key value cache. So we will cache all the data in order to not spend a lot of compute. Imagine that you will have to call the compute each time you need to switch from a string to a number. It's not like very efficient. We added no padding too in order to ease the loading of the queries, because otherwise it's like we will have to wait for new queries to happen. So in the end, with the key value cache plus the no padding, we are able to have like a page attention mechanism, so which is quite good. And we also added like the continuous batching, because when some like a user is sending like a request, the model and the TGI will start to answer token by token, and you have just to let you know that the first token is always like more complicated to generate than the other one after. So you have one user that will have like the answer, and another user will send a request, and we will have to manage like it in the memory of the GPU, and to to do it in parallel, some kind of, because it's not really in parallel. Anyway, we also worked on the quantization, which is good and not good at the same time, because it's for me it's like your decision, because you will have less performances of the model, but at the same time you will use less RAM. So it's some kind of trade-off that you have to do or not. So we also added like an improvement, which is a speculative execution. So we are trying to guess what will be the next token, because tokens are generated one by one. So we tried, because we have like a lot of compute, so we are trying to guess, and sometimes it works and sometimes it's not. So at the end of the day, we are here with like a great project with like a lot of optimization about like the latencies. We'll talk a little bit about throughput when I will talk about Hugging Chat. We are able to handle like concurrent requests, which is not like obvious. And we are able to stream like tokens, and it's more like natural. So you can see like the two differences between like streaming and not streaming. So we saw like the big features, or I mean optimization that we did. So how to use TGI. So it's very simple, again, and it was like a decision that the team made, was to be a container-only application. So it's very easy to use. So you just have to declare the model, which is a model on the hub. So remember, we have more than 1 million of model on the hub. And then you can use a volume if you want to optimize, like if you want to do sharding as well, and if you want to not reload the data again, which is good because it won't like download the data from the hub at each time. So you just have to run like Docker run, and you are ready to go. You need to define the number of GPUs that you will use, the ports, and here it's not the latest version of TGI. The latest is 1.4. And you just have to call the generate with a number of tokens, and you are ready to go. So what I did, it was maybe 3 months ago. Okay. I was like in Chicago at the KubeCon, and I started to work on a Helm chart in order to deploy it on Kubernetes. It was very interesting because we do it like internally for our needs, and like I talked a little bit about inference endpoint, and it's relying for some kind of models on TGI. So I wanted to like to help the community to use TGI on Kubernetes. So I wrote like this Helm chart, which is very simple. And after that, I was just looking at the pull requests that were available on the hub and on TGI, and there's one that is very good at the moment. So I added the link here if you want to have a look, and it's well documented and it has been created by the community. For the moment, it's not like integrated in the project because it's still like a discussion that we want to have in order to know if we want to be Docker only or compatible with Kubernetes with Helm chart. But anyway, we'll see in the future. So we are using also Hugging Chat. No, we have some kind of open source. It's an open source project which is called Hugging Chat. You can see like the two links below. You can use it, download it, and we are using and it's also like available on the hub for free. You can use it like and behind the scene we are using TGI. And what we did is to optimize the parameters of TGI in order to have the maximized throughput. Because we are not like in a production environment, we are more like sharing it with the community, and we want to have it like for the maximum of user of the community. So, and it's for free. So if you want to use it like internally, you can use it Hugging Chat, I mean deploy it on your environment. You can deploy like TGI, and you can optimize your parameters in order to reduce the latency as well. A few words about what we are doing at Hugging Face with Kubernetes. So everything is Kubernetes. I mean, we are working on AWS currently, but everything is EKS. So I talk about spaces with 20,000 applications that are running. So just spaces is like maybe 500 instances running in parallel. So it's like a huge infra. So we also have inference endpoints as well, and like also the dataset viewers that you saw in datasets. And we tried, as we are like giving it for free to the community in order to help the community to grow and to use like models as well. We are working on a lot in order to improve like the way that we are using the instances. So we have like a high density of pods on the nodes. So we have up to 250 containers that are running on one node. So we worked a lot in order to improve. Otherwise, like our cloud costs, like they could have been crazy anyway. And we did like some optimization, like how to pull images in Containerd. Yeah. So we are working a lot on the infrastructure as well, and we are working a lot on library too. So I wanted just to add like that we are hiring, and especially in the open source field and infrastructure as well. So SREs, MLOps, yeah, feel free to have a look at our vocable, and yeah, and thank you for your attention.